In this lecture, we're just going to talk a little bit more in depth about a few things to start categorizing or distinguishing different types of carbohydrates from one another. So the first slide, I just want to share this table with you, and I'd encourage you to even print this out or make a version of it for yourself in an Excel file, or handwrite the chart or something and add to it also, and perhaps even add on another column for food examples. But we talked through, in the previous lecture on carbohydrates, we talked through monosaccharides and disaccharides, and we also looked at oligosaccharides and polysaccharides. So technically, simple sugar is a 1 or a 2 molecule sugar. So when we have disaccharides, those are also categorized as simple sugars. So monosaccharides, disaccharides, simple sugars, these are all synonymous to an extent with each other. Complex carbohydrates, really we're referring to those polysaccharides that are long chains of molecules that are hundreds or thousands of glucose molecules bound to each other. And then a third category of carbohydrate, which we really only can sort of start talking about as of the past 50 to 100 years, where we have really extensive processing and refining of what were otherwise whole foods to then wind up with kind of manufactured food products. So if I were to have a food column over here on the right, the refined or processed carbohydrates would be pretty much what you find throughout the grocery store. So bread products, chips, crackers, breakfast cereals, tortilla wraps, English muffins, the whole 9 yards. Those would be our refined or processed carbohydrate foods. So to be frank, these I sort of consider as perhaps additions to a diet, but rarely would I include refined processed foods in the context of a healthy diet. So let's briefly look through structure and where we find them. So mono and disaccharides, again, 1 or 2 unit sugar molecules. They're naturally occurring in fruits and vegetables. And the effect on the body that these have, so they're a really quick source of energy. So especially think of like in the summer months in upstate New York anyway, think of having all the berries that we have available, the peaches, the nectarines, the stone fruits, the various melons, the apples. So all of these are going to be a really great snack when we just need a little bit of energy, or if we're kind of like in between meals, or if we're on the go. These are a great quick source of energy, or even if we're like out for a 2-hour bike ride or something, or hiking all day, fruit can be a really good source of quick energy snack. Another important thing to note though, when we're talking about whole foods, the simple sugars that we find in whole foods always necessarily are accompanied by other nutrients, specifically fibers, water, and depending on the food, any assortment of various vitamins and minerals. This is something that we really don't see once we start talking about refined and processed foods. Complex carbohydrates, again, the polysaccharides. So these are 3 or more sugar molecules bound together to make a really big, long, complex chain, again, naturally occurring in plant foods. So these are broken down a lot more slowly compared to the monosaccharide or the disaccharide. They do provide much longer lasting energy, again, because there is theoretically, there would be more glucose molecules, but specifically because of the way they're bound to each other, we have to really do more digestive work on complex carbohydrates, which means we just sort of have a slow, steady release of those glucose molecules into the blood supply as we digest the complex carbohydrate. Versus any sort of simple sugar food, we can actually start absorbing some of those glucose molecules right out of the mouth. So we do much less digestive work on simple sugars. But again, noting that simple sugars, as they naturally occur in whole foods, also have fiber in them, right? And depending if it's a vegetable like a beet or a carrot, we'd see some simple sugars there, but also a lot of complex carbohydrate and fiber. So putting these two things, having these two things together in a whole food, which we do commonly see in fruits and vegetables, kind of gives you both things. You get a bit of quick energy right away, because some of that simple sugar you can absorb in the mouth, but then you do also have this longer lasting energy source as your body breaks down those complex carbohydrates in the stomach. And then again, gastrointestinal health because of the fibers. So then our last row here, the refined carbohydrates. In the next PowerPoint, I go through what refining looks like, particularly with grains. But what we find is as we kind of process or refine whole foods into something else, we tend to lose a lot of really important nutrients like fiber, antioxidants, which could be any number of vitamins or minerals, but there are some antioxidants that are unto themselves and not a vitamin or a mineral. And then phytochemicals is this other classification of nutrients that we're sort of ever continually discovering, right? Because as we sort of see in Michael Pollan's book, nutrition is it's a young science and it's a very evolving science. So what we know now is only what we think we know. And as the science continues to evolve and develop, we are certain to find some things that may potentially contradict what we think we know now. So the structure and occurrence of refined carbohydrates. So they would be, refined carbohydrates are not naturally occurring. They only occur due to manufacturing processes that humans impose onto them. And so when we do that, we separate sugar or in some cases the starch or the fiber from the whole food that originally was. We see this primarily with grains. We refine grains into, well, first we do a lot of refining, pulling the fiber, pulling the antioxidants, pulling the vitamins and minerals out, and then we mill into flours. But we will also do this with various fruits or other types of succulent plants to pull syrups and different sugars out. When we make, again, pastries, crackers, chips, pastas, candies, all of these things are made from refined grain or refined plant sugars, and thus have a very different effect on the body compared to naturally occurring simple and complex carbohydrates. So when we eat refined or processed carbohydrates, we basically get this big influx of calories because we're getting those glucose molecules, but they're now no longer balanced by the other nutrients that were inherent in the whole food, and definitely no longer balanced by fiber. So what can happen here is we can digest these foods really, really rapidly because they basically act as simple sugars. They act like simple sugars in the digestion, but not being balanced by the complex carbohydrates that generally accompany the naturally occurring simple sugars. So in this case, with refined processed carbohydrates, we can digest glucose molecules way too quickly, so quickly, in fact, that we start to throw off our body's capacity to regulate glucose in the bloodstream, which is insulin's job, and we'll see that there's actually a video in the content for this week to introduce the role of insulin. So anyhow, this is sort of one of the major contributing factors to the onset of type 2 diabetes and the prolonging of the disease too. So once we start to pull these types of foods out of a person's diet, we actually pretty rapidly start to see a reversal of type 2 diabetes. Yeah, so glycemic index, if it's less than 55, this indicates that the food is more slowly digested. Above 55 indicates that it digests very similarly to sugar or sucrose. With glycemic load, anything above 20 is considered a high glycemic load. I hope I'm not losing my recording when I jump back and forth like that. So if I do, somebody please shoot me a quick email and I'll try to amend that. So looking at glycemic index and glycemic load, it's really useful actually to see how certain foods rank index compared to load. I'm not going to spend too much time on the refined side because it's kind of what we would expect. All of the glycemic indices are above 55 and all of the glycemic loads are pretty well above 20. But again, you see these are all just manufactured, man-made foods. You know, there's no rice cakes, Bush or Lifesavers tree or vanilla wafers plant, right? We make these up. So on the right-hand side, we see actual food that naturally occurs in nature. So this is where I think it gets really interesting. If we look at the glycemic index, so again, this is kind of literally just comparing the sugar content per volume of this food to the sugar content of straight up sugar, 100 grams of sugar. So parsnip actually has a relatively high simple sugar content. So it is the baked potato, so it is millet, so it is boiled broad beans. To be honest, I'm not actually sure what broad beans are. I would think just those types of legumes that aren't like the classic green bean. Couscous, sweet potato, and brown rice, and on down. Carrots, also you see 71. But so what's interesting then is to compare the glycemic load to the index of these foods. So again, because these are all real whole food naturally occurring, you actually notice that they all have a glycemic load under 20. So these all have what we would call a relatively low, like really low, or moderate glycemic load, meaning that the overall impact on blood glucose is kind of negligible, right? We would see a normal rise in blood glucose because that's what happens when we ingest carbohydrates, but then we would see a normal reset to homeostatic levels of blood glucose. Whereas with the refined processed foods, all of these are going to throw blood glucose out of whack and cause issue with insulin production and insulin management in the body. All right, and then lastly for this presentation, how much should we eat? So the recommended daily allowance is about 130 grams per person. To be honest, that's low for some people. What you'll see for this week's lab assignment, I asked you to do some calculation with this AMDR range, so the acceptable macronutrient distribution range, 45 to 65% of daily total calories. So remember in the beginning of this course, we calculated our daily estimated energy requirement, which is the total number of calories we need in a day. So once we know that number, we can do a basic math and say, okay, well, let's say I'm going to have 65% of my total caloric intake coming from carbohydrates. So we take 65% of whatever your EER is, and now that's the number of calories that you would take in a day coming from carbohydrates. You'll find on the course content for this week that I say carbohydrates provide 4 calories per gram of carbohydrate. So then you would do another simple division and take whatever your total carbohydrate calories are for the day, divide it by 4, and that will tell you the number of grams of carbohydrate that you should theoretically take in a day. And then this last bit here is really important, I think. The added sugar piece. So added sugars, which means foods that are sugar that's not naturally occurring in the food, should amount to 25% or less of total daily energy intake, or in other words, for women, less than 6 teaspoons a day and less than 9 teaspoons a day for men. Each teaspoon has about 4 grams of sugar. Each teaspoon of added sugar has about 4 grams of carbohydrate. 4 grams of sugar. So you'd want to keep that under 24 grams of added sugar. So this would not include fruit sugar or sugar coming from the beet or the carrot or the potato. This would be things like your breakfast cereals or any sweetened beverages or any sugar added to coffee, muffins, waffles, bread products, all those things. Those are added sugars. And so really a basic suggestion for how to eat carbohydrates is to simply eat more fruits and vegetables, beans, and whole grains, and to choose a variety of these foods. So these are really your healthiest sources of carbohydrate in the diet.